showed you guys the answers. So if forget why we were missing some people. I know we've just been missing some people just because illnesses. Orchestra was Friday, though, wasn't it? Yeah. So tomorrow, right as this said, tomorrow we will be working on Chapter 4 Mastery again. Those of you who did not get a chance to start it, you will. We worked as partners on Friday, and same partners. That will continue to be the case. We may work with the same partner tomorrow. Again, I'm out tomorrow for CPM training. I'm over at the WEC, Worthington Education Center. WEC, W-E-C. So, if you need to review 454 with a peer, please check on that one. But now we're going to reverse the process, so everybody needs graph paper. Graph paper. Graph paper, the paper with the graph grid, yeah. No, there shouldn't be. Sure, yeah. I need to just make another thing that says team test now, or just test now. So we talked about the different parts of the equation, and we want to remind ourselves about it. So whatever you want to hedge your paper, we're going to do 416 and hopefully 417 both today. We talked about the standard form of the equation. It's okay, I'll make this take a long time. Being y equals mx plus b. Yeah. Correct. What? Well, right now we're still in 6, but the homework is actually from 7. We started 6 last week, so 6 is homework. We'll see how far we get to. I'm hoping we get into both. I'm not going to collect your math terminals. So assume that 417 is tomorrow's homework, but you can just get the stuff done. It shouldn't be too bad. 71, pay close attention to that problem. It's a checkpoint problem. So if you are able to do that, you should be ready for the mastery stuff. If you're not, check the checkpoint materials in the back of the book. It walks you through the problem. So if you can't do 71, it tells you flip to whatever page in the back of the book to check the solution process. We got our equations like this, and we have a couple special names for pieces of the equation. Well, actually, we have a special name for each part. But the x and the y, those are easy. Independent variable, dependent variable, so those are just our variables. What are the other special names for the other parts? Who can tell me what is called what? Who here? M is slope. So y equals the slope times the x plus, or it could be written as minus. Date today, 22nd. The y-intercept. And by the way, that's a hyphen. Please do not confuse that for... Yes. Now we also know that slope is the change in y over the change in x. And that's how we get to what they call the growth triangle. The up, then over, it makes a triangle. So try this on your graph paper. For each of these, just make yourself a little XY coordinate grid. Plop your x or your y-intercept on, and then show your growth. And I'll give you 2 minutes. I'm probably just going to show you guys the answer and take questions if you need to. So make sure you're working with your partner, checking that you guys have the same stuff. Okay, or I guess a couple third classmates have decided we'll make all of these on the same graph. That's okay. I guess if you want to make one big X, Y, yeah, you use different colors or just label the lines, like line A, line B, line C. Don't ask me right now. You have a partner. By the way, because I know this class probably has more than the other classes, math counts. If you still need to turn your commission form, we can do so. Hey, right now, we should be scaling our graphs whenever possible 1 to 1. So you should try to make one box equal 1. Like whenever possible, for ease of graphing, then you should give yourself enough space. What do you mean you don't have enough space?
Like, no, that's a lot of space, like,
Really?
on your graph.
All you need it to do is like be, I don't know, 10 tall, maybe 10 wide. Like I don't need much of this space. And I don't need, depending on how I make it, all of this space. But you got plenty of paper. You can use mine.
But I have to put it all in my math. Okay, I'll do the next one.
Let's do this. This can be fun. So Piper, would you like to grab one of these? No?
That's always what happens when you don't want to do it.
Will not here. Kaylee, do you want to go? May? Zin, you want to grab one of these? You don't know? Wow, you guys are really making me confident. Izzy.
Can I finish?
I was going to ask what one you want. Alex and Boone. You can say no. I'll just... Oliver, you want to grab one up there? You want to do an A?
I'll do A because that's the only one I have.
Thank you.
I was trying to finish it, that's why I was like...
Alex B, do you want to grab one up here? C, sweet. Thank you. Rachel, you want to do D?
Are each one of these individual points?
No, so the boxes, don't pay attention to the green dotted. I just did that because those you could see that. So that's like 1 up, 2 up, 3 up, 4 up.
He said do it by one.
Can't see it in my own head.
I know, hard, right? No, hard. Hard to make your own head.
It is hard to see through.
I know, right?
5?
Sure about that?
Okay.
Oh, never mind.
Yes, I'm sure. The next point is too high.
You're good. So if you can't show the next point up, could you show a point back?
I could.
So instead of going up 4, right 1, do the reverse.
So go left 1, down 4.
Mm-hmm.
So it would be right here.
Now I'm going to help you out with the line. We should then have a straight line looking like that. There's your A. So B, I would choose a different color. Well, you can. Just pick up whatever pen you want and I'll make it green for you.
Oh, no, I don't need that.
Oh, yeah.
This one should be right.
Okay.
7 + 3 is 11.
Grab a ruler if you need to connect them with a ruler.
Yeah, I probably could have grabbed it.
Wait, I know how to do this now.
I was just trying to finish my graph, and then I was like,
Did I already almost use it on
We can cheat and use our own. You're okay. You can do that. Oh, keep- There's B. And who was C?
Wait,
Can I see?
no, I'm good. No, I'm good. I'm good.
So this is 1, 2. Yeah, pay attention to the boxes, not the green. Yeah, the screen's slightly off. It's okay.
Oh, okay.
I just get used to it. Now, what do you notice about Alex's line that he's making compared to all the other lines that we've seen? It's going down. Why is it going down? Okay, we'll cheat. Make a straight line like this. Why is it going down? Ah. We'll make it look. Thank you very much, Alex. Why is it going down? Alex's graph is perfect.
Because it's minusing, it's negative 3x instead of like 3.
So the growth that's been described is negative, right? So negative growth loss. And D, Rachel? Right?
Oh my gosh. No, we're not on D yet. I know, but I'm not there yet. I'm going to start at 8.
I'll just tap on the screen. Yeah. I just get used to it and I forget that it goofs with you guys. But I want to give you an opportunity. Because I just get used to it.
What the heck?
Oh, we could have cheated. Nice. Now, I'm a little confused because Rachel didn't show. She didn't show a wire set. Is her line wrong? On each of these lines, what I need to make sure we're aware of, there are actually arrows on all of them
Oh, there is one.
because the behavior continues both directions. So if Rachel wanted to draw the rest of her line, it keeps doing the same thing. And here is where that y-intercept happens, at -1. What number is in front of the x if there is no number there?
What?
A 1. Careful. That x, the y equals x minus 1, in front of the x. I don't have to say good morning, 1, Bilal. Good morning, 1, Tyler. It'd be awkward, right? I'm going to start to tell you that there's one of you every time I say no. When we talk about x, there is one x. So if you need to, if that goofs with you, when you see something like this, rewrite it as 1 times x minus 1, because there's actually a 1 there.
Then wouldn't it go up 1?
It does. Up 1 over 1. Up 1 over 1. Up 1.
Oh, she just. Oh.
It's a little wavy, but.
Okay.
So the stair step pattern there is the same up as it goes over. If you go up 3, go over 3. Go up 7, go over 7.
Go up 7, go over 7.
So, yeah, I mean, anything over itself makes 1, right? So rise over 1.
Oh, yeah, rise over 1.
All right, we are essentially going to skip the rest of 416. So I would label a header in your notes for 417 or some kind of note that we're moving on. Just, I mean, if it doesn't make it in, it's okay. We're just kind of trying to get done with the chapter. We're going to call this the web. The web. Not like your web group or your web leader. Our web now, for how we can show these relationships, this constant growth relationship or constant change, can use a table, a rule, a graph, or a pattern. So somehow on your paper, I don't really care how, show that we can convert between any of these. Table, rule, notice that all of these arrows go both directions. You should be able to work any direction from any of these to any of these. Given just one of them, we should be able to derive all of the others. So, if we look at 464, and I'll zoom in and I'll put it up here, I want you and your partner to take a moment to try to figure out the 3 missing pieces so that we can describe figures 0, 1, and 2. So just A, and if you get done with A, move on to B.
So we're trying to figure out.
There's the web. Graph, table, rule, pattern. Really, order doesn't matter. It's just showing that graph, table, rule, pattern. Those are the 4 ways. I mean, I wish, but I doubt it's gonna happen. All right, let's see if you can do this in 2 minutes. So what are we missing? What 3 things are we missing?
Pattern.
Pattern,
Table.
table,
And
rule.
rule.
Rule. We have graph. We need pattern, table, rule.
You want to figure out the rule first?
Yeah.
Okay, so that'll help everything else.
Yeah.
What if I put it in one time? So we have to figure out how much it's going to be. No!
For everyone.
Wait, how do you your key chart or
If you can describe the pattern, all other things should be able to come. Where are my cards? Oh, you're over here. Alright, now we shuffled since everybody said no for the last one. May, if I asked you where you start here, what would you say? If I just asked you where do you start? Now, my line doesn't technically start, it could keep going, but if we look at where our line looks like it starts here, where are you starting? Start at 2. Sky, if I ask you what we go up by. Up by 3 for every figure number. So, Sky looked at the fact that when I go over 1, up 3, can, Miss Koenig, we make a rule based off this? Can we make a rule, that mathematical equation?
wait, what's
What is 3x, you said? 3x plus 2. Yeah.
What does that say? It says like and start at and then it says
Start at 2, sorry, and go up.
oh.
So, or increase, or add, whatever, add, increase, whatever you want to say, change. So pattern is just asking you to explain or describe it. If you were telling somebody, okay, start with $5, gain 2 every day, or something like that. So that too, if you want to show it visually, you can describe the pattern with verbally, or you can describe it graphically. Now, your pattern that you use to describe, if we show it with blocks, might be different than somebody else's. That's why I wanted to describe it with words to begin with. So then my XY table, well, we said when X is 0, Y was 2. When X is, what do we want, 1 and 2?
1 is 5,
1 is 5,
and 2 is 8.
There we go, and we could keep going. Now, if we wanted to do this with blocks, you'd have to decide how you show the growth of 3 every time. Some people would be very simple, and they would say, okay, start with 1, gain 3 every time.
Wait, but you
Gain 3 every
you
time.
start with 2.
Sorry, start with, my bad, start with 2. But other people will get really creative, and they'll say, okay, I'm going to start with 2 and add 1 on that corner, 1 on that corner, 1 on that corner. Or what, it can look different. So when we come to show me, there's not well, there is wrong, but there's not one right answer. Right? There's multiple ways to do this. I could do it really weird too, where you start with 2 and then you build pyramid almost.
Yeah.
Give it a shot.
Oh, okay.
Now, hold on, let me make your life easier for a minute. If you're just trying to draw a quick graph, you may just do positive x, positive y, show where the y starts, show what the line does, and then show a growth triangle, either up and over or down and over, and write on there what, bless you, write on there what happens.
Oh no, I got to do one more.
I'm doing this wrong. I have to go on 14. That's why it was super weird. I don't remember that. So 1 times -3.
Wow, that is what?
What are you wanting?
Is that how
I don't know. I'm like slopping a graph up there.
Okay.
Because I'm going to show you guys a really easy way to just make a fast graph
Oh, I did this.
if you're not caring about scale and
Oh yeah, is this where you just don't add the stuff and you just like.
in a way. Oliver, if I were going to start to make my graph, where do I start at? 14, right? Because that's my y-intercept. Even though, please hear me when I say that's not technically our start. We could have started way out negative. That's just our reference point. So this is 14, and I label it 14. I could also label the point 0, 14. If I then go to describe my growth or my change, Alex, what's my change as my graph moves?
Your change is -3.
-3, right? I go down by 3. So I could show that my next point is 111. And then because we talk about those growth triangles, I can show -3 when that goes 1. Or if we bump over here, I can show that here, -3 when that goes 1. Now this is not to scale. This is not pretty. Notice there's no graph behind it. There's no grid. This is just you're trying to slop a quick graph. But then what we need to worry about is out here. So this would be like 2, right? 3, 4. I did think about the fact that at 4 we're at 2. By the time I get to 5, this will be negative, right? So I cross the x-axis between 4 and 5. So 5 would be some point down here. If you're just trying to slop it. Alright, so my pattern, we could draw a couple of different ways. What rule could we make? Alana, how could we write this algebraically? Like the y equals?
Oh, so y equals x
Negative what?
-3
Yeah, your change, that -3x
and then
plus 14, exactly. Thank you very much. The pattern, Rachel, how would you describe that?
Oh,
How would you say it to somebody? Like if you were trying to help somebody build it, like tell them, okay, you need to start with,
like x times
you're trying too hard. So if you're going to make this with tiles, figure 0. How many tiles does it have? 14, right? So we need to start with 14 tiles, however you would make it, and then do what? You're thinking too hard. Think about it visually. So in your brain, right? Put 14 tiles in. Now we take a step to the next figure in your head. I should go this way. How many tiles does that one use? We take a step to the next figure. How many? So we just take away 3 tiles. So if you're describing the pattern, don't overthink it. Don't think about the math. Don't say start with 14 tiles. Take away 3 every time we change figures, every time we take a step, whatever you want to say. We start with 14, take away 3 every time we move or take a step or increase figure number, whatever you would say. And there's a lot of ways we talk about this. It comes down to the situation. So that might be days or months or years or who knows. Like I just bought, so we made an IKEA trip this weekend, and I bought a bamboo shoot at IKEA. I like plants. Our house needed more plants. So I could track this bamboo growth and say my bamboo started at 18 inches, I'm guessing, and grew an inch every month or something like that's why we use linear situations like this, is to describe something that changes consistently. And that's why we want to be able to talk about the pattern. I don't know that for my bamboo, but if it was, which I do think bamboo actually has a constant growth rate, most trees do, but then I could say something like that. But I would need to track some data. If it stays the same, if every month it does the same thing, then that makes it consistent. If this month it grows by an inch and next month it grows 2 inches, it's not consistent.
And the month after that goes 1 more.
That's a different type of relationship. Alright, so now when given the pattern, okay, so check this out with me.
Oh no.
4x plus 3. I saw the word graphing calculator.
Oh no, your attitude. Alright, so we're going to look at these figures and decide
Oh, that's a figure one.
a table, a graph, and a rule for the pattern that we see. So, if somebody wanted to describe it to you, they wouldn't be able to quite yet because you only have figures 2, 3, and 4. That's one of the issues with just drawing the pattern. We might need to work our way back. And then here's the real question. In the first group, we'll throw some dum-dums on this. First group who can tell me which figure would have 79 tiles, you guys can have dum-dums. So there you go. That's your choice. What if I didn't? What if I said if you don't have a book out, that's your own problem? What? You guys are supposed to have a book out.
Thank you.
What is the
Okay.
You're on plus 2 5.
I got it. We got a copy it down.
Wait, what figure? What figure? 72?
No, how many was out of that?
Tiles.
So minus 11 is 1.
Technically, Alex beat you guys,
Plus
but
4.
I'll let you guys win.
Can we have dum-dums too? Why can't everybody just have dum-dums?
I need to, honest answer, I need to replenish my candy supply.
Well, then you do that.
If we worked backwards, how many tiles would figure 0 use?
Eddie, I got the Oh, I got it. It's 50/55. Yeah. What?
I don't know. We have to go.
If we worked backwards, Rachel? 3. How did you figure that out? What is the growth of each change? 4. How can you visualize that? Let's see if you had to like explain to somebody how this actually looks. Zan?
Well, I look at it and I see that the one thing that stays the same is there's always 3 on the end.
Mm-hmm.
And so then I was like, okay, so that has to always be there. So I looked past that and so it always has like an L of 3 and 1. And if I kept taking them off, which was 4 at a time, I would end with 3.
Who plays Tetris?
I do.
Like, so start to visualize this stuff. That's the geometric side of things. Is what. So if I want to go from figure 3 to figure 2 and go backwards, you remove that. Which this is a Tetris piece. So you remove that, and that was there to get to figure 3, or to build figure 5 from figure 4. You just drop down an extra one. Get that thing to go. But yeah, so we start with 3, grow by 4 every time, and once I know that rule, Alex, how'd you find your answer so fast?
Well, basically, first I did find the rule, which was 4x plus 3.
Okay.
And then I just subtracted 3 from 79 and then divided 76 by 4.
If you don't have this yet on your paper, please write this out. If we set up an equation where 4x plus 3 is going to equal 79.
Good morning, Lauren Carpenter. Please stop at the office. Lauren Carpenter, please stop at the office. Thank you.
Exactly what Alex said. We can take 3 away from both sides. That will then give me 4x equals 76. And that's how he gets to x equals 19. Because to get x by itself, what'd you do between this step and this step?
I divided 4 from each side.
Divide each side by 4. So Rachel, Mina, and Alex see me after class. Are you? It's clicking it.
It's not a good day for the transportation class.
That thing never wants to work.
No, it's mad that you didn't give all of us.
Oh, sure
it's mad
it is.
that you heard it.
So that's 416 and 417. I'll give you the last like 8-ish minutes to work on homework since
As he was
you might have some extra problems.